So, one of the things that I wanted to try to do is to help a little bit with this idea of proportionality and determining whether or not a function is directly proportional, inversely proportional, or linear or nonlinear. I know there's been a lot of questions, a lot of confusion, and there's just not a whole lot of information out there about it. So, I want to take a few minutes here to try to clear some of those misconceptions up. First off, a directly proportional relationship, or you might see it as a direct variation, is a linear function in which the graph of a line goes through the origin. And notice that I have linear because it does make a straight line. And it can be expressed algebraically as y equals k times x, or it could be k equals yx, where k is just a constant number, and it would be the same number throughout. So when we think about a directly proportional relationship, it might be something like y equals 3 times x. Just the value of y is determined upon the value of x. If x were 1, y would be 3. If x were 3, 3 times 3 is 9, y would be 9. So that's what we talk about when we mean algebraically as y equals k times x. Now, how do we determine whether or not a function is directly proportional? Well, one of the things we can do is to determine if it's directly proportional. One of the things we could do is divide, and I'll show you an example of that in just a second. The other type of function is an inversely proportional relationship. Now, whereas a directly proportional relationship forms a straight line, an inversely proportional relationship is nonlinear. And it can be expressed as k equals y times x, or y equals k divided by x. Notice where the x is here. We're going to divide by whatever the x value is in our function. Now, one of the things we could look for is to see whether or not one value increases the x or the y, or the other value decreases, once again, the x or the y. To determine whether or not a function is inversely proportional, we would multiply. For directly proportional, we divided. For inversely proportional, we want to multiply the x and the y values. If you get the same thing each time, you know that the function is inversely proportional. The other thing here we have is just a linear function. A directly proportional relationship is linear, but the difference in that and just a linear function would be a function whose graph is a straight line but not go through the origin. For example, we might have y equals 4x plus 3. Now, y is determined upon x. If I had x here and y here, if x were 1, 1 times 4 is 4 plus 3 is 7. A directly proportional relationship would go through 0, 0, the origin. If I put 0 right here for x, y would be 3 because 4 times 0 is 0 plus 3 is just 3. So I know that this would not go through the origin. Now I could pick several other numbers as well. But one of the look fors when we're trying to determine whether or not a function is linear is to try to see if we can find a pattern on the x and the y's. And once again, I'll show you an example of that in just a second. So here we go. Let's look at this. An example of a question you might say something like this. Describe the following as directly proportional, inversely proportional, linear, or nonlinear. So I have these x values and I have these y values. So I want to think to myself, I want to try to first either divide or multiply, because I know if I divide and the values are the same, then I have a directly proportional relationship. If I take, because algebraically, a directly proportional relationship, y equals k times x, or it could be k equals x divided by y. I'm sorry, y divided by x. So what I wanted to do is to divide each one of these I want to divide the y value. Get this straight first. 12 divided by -4 equals a +3. -6 divided by -2 equals a +3. 6 divided by 2 equals 3. 12 divided by 4 equals 3. And 15 divided by 5 equals 3. I think I wrote the wrong thing down again. So what we're doing is we're dividing y divided by x. If I get the same thing each time when I divide y divided by x, I know that I have a directly proportional relationship. So I know the answer to this question is directly proportional. Now, what does the 3 represent? The 3 actually equals my k. So if I were looking to try to form an equation for this line, it would be y equals k, in this case it's 3, times x. If I put -4 in for here, -4 times 3 is -12. If I put -2 right here, -2 times 3 is -6. And then if we were to actually graph the line, let me plot some points here. -1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then -2, -6, 1, 2, 3, 4, 5, 6. Now next year, as you get into a little bit deeper algebra, you'll learn the slope of the line here is 3, and then you can draw these points a whole lot faster. 1, 2, 3, 4, 5, 6, and then 4, and then 12. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'll erase this line. And then I would draw a line through all of these points, and you would see that what we have is a directly proportional relationship because it's linear. Sorry about the line going a little crooked. And it goes through the origin. So, look at the next question. Which of the following describes an inversely proportional relationship? Well, I know if it was directly proportional, I needed to divide. So since it's asking about inversely, I want to do the opposite of divide, which is to multiply. So I would start off by multiplying these two guys together. -4 times 16, which is 64 negative, which wouldn't be the same thing as -8, which wouldn't be the same thing as 0. So I know this could not be inversely proportional. If I multiply once again, 9 times 18, 162 maybe, 128 on this. I know that this is not inversely proportional. If I multiply here, 3 times 6, 18, 5 times 8, 40, not the same. But look, 12 times 1 is 12, 6 times 2 is 12, 4 times 3 is 12, 6 times 6 is 12, and 1 times 12 is 12. And one of the things that I said you might want to look for is if one value goes up and one value goes down. Here the x values are decreasing and the y values are increasing. So if I look at the graph of a line, because I think this is important, x is 12, 5, 10, 11. If x is 12, y is 1. And then x is 6. Y is 2. And then x is 4. Y is 3. Excuse me. X is 2. Y is 6. And then 1 and 12. And you can see that the graph of the line, and you'll just have to kind of excuse me right here, is a non-linear function because it does not make a straight line if I graph those points. So I know that this is inversely proportional because the x times the y, remember inversely proportional relationships, if we go back and look how it's expressed algebraically, that I can multiply k equals y times x or y equals k over x. Y equals k over x. In this case, the equation would be 12 over x. If I put 12 right here for x, 12 divided by 12, the y would be 1. If I put 6 right here for x, 12 divided by 6 would be 2. If I put 12 divided by 4, that would equal 3. So this is representative of an inversely proportional relationship. The other thing is just a straight linear relationship. And one of the things we want to do is to kind of look for a pattern between the x's and the y's. Like right here, x plus 1 is 3. That's plus 3. And this is plus 2. And this is plus 1. And 5 to 8 is plus 3. This is plus 9. This is plus 6. So I really don't have a definitive pattern here. So that would not be a linear relationship. Here I noticed that these values are going up and these values are going down, which to me looks like it would be some type of inversely proportional relationship. But we can see right here, that's plus 1, that's a plus 3, that's a plus 3, and then you got a plus 9. So this would not represent a linear relationship. But if we look right here, we have a plus 2 to 6, 6 to 8 plus 2, 8 to 10 plus 2. And then 7 to 13 plus 6, 13 to 9 is a plus 6, 19 to 25 is plus 6, and 25 to 31 is a plus 6. So it looks like this would be a linear relationship between x and y. Now we can prove it by going to the graph again. Now I know my graph is really, really small, but if we go over 2, 1, 2, and up 7, 1, 2, 3, 4, 5, 7. Sorry about that. Try to make this a little bit bigger. 2, 1, 2, 3, 4, 5, 6, 7. Goodness. And then 4, 1, 2, 3, 4, 5, 10, 11, 12, 11, 12, 13. And then 6 and 9. 6 and 19. I'm sorry. 5, 10, 15, 19, and then 8, 25, 6, 7, 8, 10, 25. Okay, and then if I connect the dots, you can see that we have a straight line, but it would not go through the origin because the origin is located right. Make this a little bit smaller. My origin is right there. So the line would not pass through the origin, so it would just simply make it a linear function. So I hope this helps. I hope this clears a little bit of the misconceptions up. But if you have any other questions, just feel free to ask.